In this video, we're going to be looking at proof by induction using divisibility. So proof by induction that 3 is a factor of, which is the way these questions will be stated, 4 to the power of n minus 1. So let's look at n is equal to 1. Is 4 to the power of 1 minus 1 divisible by 3? 3 is divisible by 3. So it is. Okay, we're going to assume n is equal to k. Therefore, 4 to the power of k minus 1 is divisible by 3. And the key to these ones, that means that 4 to the power of k minus 1 is equal to 3 times a number. We'll call that 3a. So we're going to write 4 to the power of k then is equal to 3a plus 1. So slightly different than your proof by induction of a series. Now, when n is equal to k plus 1, we get 4 to the power of k plus 1 minus 1. And is this divisible by 3? So as we know from previously, the key is always the assumption. So this 4 to the power of k, you can see, is going to come from 4 to the power of k. If we split 4 to the power of k plus 1, we're going to get 4 to the power of k by 4 minus 1. And what we want to do is we want to split that 4 into something else. Or 4 to the power of k into something else, which is our 3a plus 1. So we have 4 times 3a plus 1 minus 1, which is 12a plus 4 minus 1, which is 12a plus 3. Now, if we can show that 3 is a factor of this, we have our proof done. So this is 3 times 4a plus 1, which is 3 times another number, which we could call b. So therefore we can say p k plus 1, or when n is equal to k plus 1, is true. So n equals to 1 is true. Assumed n is equal to k was true. Shown or proven true for n is equal to k plus 1. Therefore, true for all n is an element of natural numbers. So for all natural numbers, k plus 1, which is k plus 2, and so on, it's true. Let's have a look at a few more of these. So this one, we have 10 to the power of n minus 7 to the power of n divisible by 3. When n is equal to 1, we have 10 to the power of 1 minus 7 to the power of 1, which is equal to 3, divisible by 3. Yes. When assume n is equal to k, I'll just shorten this down. 10 to the power of k minus 7 to the power of k. And now we're going to prove true for n is equal to k plus 1. You guys can add all the words to this. So this is 10 to the power of k plus 1. I'll come back up here in a minute. 10 to the power of k plus 1 minus 7 to the power of k plus 1. So like previous, we can say this is 3 times a number. So 10 to the power of k is equal to 3 times a number plus 7 to the power of k. So this is what's going to help us underneath. So let's see what happens when we simplify this. This is 10 to the power of k by 10 to the power of 1 minus 7 to the power of k by 7 to the power of 1. We have our 10 to the power of k from above, so this is 10 times the 3a plus 7 to the power of k. We have minus 7 times 7 to the power of k. If we multiply out the bracket, we're going to get 30a plus 10 times 7 to the power of k. And we still have our minus 7 by 7 to the power of k. And you can see these are going to give me a 3, which we're looking for. So I've got 38. So if 10 of them take away 7 of them is plus 3 of them. And this is going to give me 3 times 10a plus 7 to the power of k, which is equal to 3 times a number, which we'll call b. We can say therefore when n is equal to k plus 1, or when proposition k plus 1 we can say is divisible by 3, and therefore we can say the rest of what we need to say at the end of these questions. So you come up with your method of what you're going to say. N is equal to 1, n is equal to k, n is equal to k plus 1. We look at a couple more of these. So is n squared plus 3n always divisible by 2? When n is equal to 1, therefore we get 1 squared plus 3 times 1, which is equal to 4, which is divisible by 2. When n is equal to k, we're going to have k squared plus 3k, and that's going to be equal to 2 times a number. So we leave the k squared on its own here to say k squared is equal to 2a minus 3k, which we're going to bring this back in at some point to help us show that this is true. So when n is equal to k plus 1, I'm going to get k plus 1 to be squared. So you can see I'm going to have a k squared in here, which you probably could identify at the beginning, plus 3 times k plus 1. It's going to give me k squared plus 2k plus 1 plus 3k plus 3, which is k squared plus 5k plus 4. So we have our assumption now. We have k squared, and we're going to replace it with 2a minus 3k, and we still have plus 5k plus 4. So we're going to get 2a plus 2k, sorry, plus 2k plus 4. And we're always the same as the last question. If 2 is a factor of this, a plus k plus 2, therefore that's divisible by 2. So we could call that 2 times another number, stick to the same method, call it 2b. So the proposition k plus 1, or n is equal to k plus 1, is true. You could write, if you wanted, having assumed n is equal to k was true. Proposition 1 was true. Therefore, true for all values of n being an element of natural numbers. Okay, let's do 2 more of these questions. So let's see, is 7 to the power of n minus 1 divisible by 6? When n is equal to 1, 7 to the power of 1 minus 1 is equal to 6. Divisible by 6? Of course it is. Assume n is equal to k is divisible by 6, so we get 7 to the power of k minus 1 is divisible by 6, so we could say 7 to the power of k minus 1 is equal to 6 times a number. So n is equal to k plus 1. We're going to get 7 to the power of k plus 1 minus 1, which is 7 to the power of k by 7 to the power of 1 minus 1, which is 7 by 7 to the power of k minus 1. Now, anytime it's divisible by 6 or whatever number, we're looking for a 6 somewhere. So this 7 can be turned into a 6 plus 1. And we'd multiply that by 7 to the power of k. The minus 1 is still there. So we have 6 times 7 to the power of k plus 1 times 7 to the power of k minus 1. And you can see now where the assumption is going to help. This is my assumption. So that's 6 by 7 to the power of k plus my assumption, which we called 6a. So if I factor out my 6, I have 6 times 7 to the power of k plus a, which is divisible by 6. Therefore, true for n is equal to k plus 1. And you blah 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 on to get your final marks in this question about all the other things that you need to say. Is 5 to the power of n minus 1 divisible by 4? N is equal to 1. 5 to the power of 1 minus 1 is equal to 4, which is divisible by 4. So that's true. Assume n is equal to k is divisible by 4. So 5 to the power of n minus 1 is divisible by 4, so we'll call 5 to the power of n minus 1, we'll call that 4a. We could say 5 to the power of n is equal to 4a minus 1 as well. We may not need to. Let's have a look here. N is equal to k plus 1. So we get 5 to the power of k plus 1 minus 1. Same as the last question, 5 to the power of k by 5 minus 1. This 5 can be written as 4 plus 1 times 5 to the power of k. So we can say that's 4 to the power of 4 times 5 to the power of k plus 5 to the power of k minus 1, which should be our assumption. It is. If I had written k instead of n, let me just go back up and change that. So we have 4 times 5 to the power of k. I'm factoring out my 4 from the first one plus, actually I should have written plus 4a first. Let me do that. 4 by 5 to the power of k plus 4a, which is what we said 5 to the power of k minus 1 was. So I have 4 times 5 to the power of k plus a, which is divisible by 4, true, or proposition k plus 1 true, and then write the rest of what you need to write to get full marks. I'll do a second video on divisibility proofs, practice all these questions and master this skill before going on and looking at inequalities.